Students, now we will solve exercise 1.1. In that first question, use Euclid's division algorithm to find the HCF of the following numbers. So first we will take this first part, that is 135 and 225. To find the HCF of these two numbers, so as per the Euclid's division algorithm method, find out the biggest of the given numbers. That is, now the biggest number among 135 and 225 will be a 225. So 225 should be divided with a smaller number, that is 135. So 135 into 2, it will be 270. So it is bigger than this one. So we will go for 1. 135 ones are 135. So we will subtract this one. So 0, 9. Okay. So now further this cannot be simplified because the 90, whatever the remainder it is there, it is less than this one. So now this can be written as, according to the Euclid's division algorithm, that is dividend is equal to divisor into quotient plus remainder. This we know. So as per this one, we will write dividend 225 is equal to 135 divisor into quotient will be 1 plus remainder is 90. This is equal to 90. Now we have to find out the HCF, means we have to go on to divide until the remainder becomes 0. So now this is not 0. So here one thing we have to follow. See, this remainder should become 0. Until that we have to go on divide. So for that what we have to do, this 135 is not able to divide 225 completely. That is, the remainder is not becoming 0. Then we have to divide this 135 with this 90. So now 135 will become dividend now. So 90 into 2 is 180. It is more than this one. So 90 into 1. So here 90 will subtract. So 5, then 4. So this again we can write this 135 dividend is equal to 90 divisor into 1 plus 45. So again this remainder is not equal to 0. So now further we have to go on divide this one. So this 45 again divide 90. Okay. So 45 into 2, it will be 90. Now the remainder will become 0. So we will write this as 90 is equal to 45 into 2 plus 0. So whenever the remainder becomes 0, then the HCF will be this one. Means whenever this remainder will become 0, very next that divisor will be a HCF of the two numbers. So hence the HCF of 135 and 225 will be is equal to 45. So this is the Euclid's division algorithm methods to find out the HCF. So now we will go for the second part. So now we will solve this second portion, that is 196 and 38220. So as per the Euclid's division algorithm, find out the biggest number of the given two numbers. So 38220 is the biggest number, and divide this number with the smallest one, that is 196. So 196 will take these 3 digits, means 196 into 2 is nothing but it will be around 392. So this is less. So 196 into 1 will go. So 196, 12 6 6, 18 10 8. This is 1. So this will take to this side 1862. That is 196 into this one. 196 into 7 will go for 7 6 42, 4 67, 7 13. This is less. 7 means 9 will go. So 9 directly we will write here. So 9 6 54, 5, 9 9 81, 86, 8, 8 9 1s 9 plus 17. This is 17. So subtract here 8 9 0 0. Okay, 9. Then take 0, 980. So 980 means 6 5 30. Mostly it may go 6 5 33 is remaining. 9 5 45, 48, 4 is remaining. So 5 1 5 plus 4 9. Okay, now remainder will become 0. So this remainder will become 0 now. So this can be written in this way equation. This can be written in the Euclid's division algorithm form, that is 38220 is equal to 196 into 195 plus remainder, it is equal to 0. So whenever the remainder is 0, then the this divisor portion, that will become the HCF. So HCF of 196 and 38220 is equal to 196. This is the answer. Okay, now we'll solve this third portion, that is 867 and 255. So biggest number will be 867. So 867 we will divide by this 255 number. 4 means it will exceed 1000. So we will go for 3. 3 5 is a 15. 3 5 is a 15. 1 16. 3 2 is a 6 and 7. So here 2 0 1. So now this will write in the form 867 is equal to 255 into 3 plus 102. So now the remainder is not equal to 0. Hence we will go for further solution. 255. So here 102 into 2, that is 204. 5 minus 4 1 5 5. So this will become 51. So this will write this 255 is equal to 102 into 2 plus the remainder is 51. Remainder again it is not equal to 0. So now we will go for further division. So 51 again 102. 51 into 2 is equal to 102. So remainder 0. So here 102 is equal to 51 into 2 plus 0. Whenever the remainder becomes 0, this will be a HCF. So this immediate divisor will become the HCF of the given numbers. So HCF of these two numbers will be 51. So now we will solve exercise 1.1 in that question number 2. In this question, he has asked show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is any integers. So now here you can take any number, any odd integer, positive odd integer. So if you divide it by 6, then the remainder will become 1 or 3 or 5 only. That is what he is asking to show us. That is, suppose this, we have seen that this is a divisor, dividend, this is quotient and remainder. So here this also can be written as A is equal to BQ plus R, where A is a divisor, B is a dividend, Q is the quotient and R is the remainder. So now here instead of B we will write as 6. This I will write A is equal to 6Q plus 1, A is equal to 6Q plus 3, A is equal to 6Q plus 5. In this way we have to show. So any number N is equal to 6Q plus R. Here remainder R, what it may be? It may be 0 or it may be 1 or it may be 2 or it may be 3 or 4 or 5. So it should be less than the value of this B, that is divisor value. So now we will write this equation in this way. N is equal to 6Q plus 0, 6Q plus 1, 6Q plus 2, 6Q plus 3, 6Q plus 4, 6Q plus 5. So we will check whether any positive odd integer satisfy this equation. So now we will take this one. Here remainder will be 0, means this is equal to 6Q only. 6Q means this can be written as 2 into 3Q. So here observe this one. This is a multiple of 2. So multiplication of multiplier of 2 means whatever, this is an integer, it may be odd or even. So the result will be even only because it is a multiplier of 2. Hence this will be a even number. So this will not become an odd number. So this is cancelled. Here also 6Q plus 2 means 2 into 3Q plus 1. This also appears like it is a multiplier of 2. 2 into something. This something means this is an integer. So this is also become even. And this one 6Q plus 4, which is equal to 2 into 3Q plus 2. Here again it is a multiplier of 2. This is also become even. So whereas in this case we will see 6Q plus 1. So here 2, 3Q plus 1 means what? This is of course a multiplier of 2. This will become an even. Any even number, if it is added by 1, then it will become an odd. Okay, this will become odd. In the same way, 2 into 3q plus 3. This is of course even. This will be added by a odd number, hence it will become again odd. In the same way, 2 into 3q plus 5. Same. This is even number, it is added by a odd number, then it will become odd. So hence it is shown that any positive odd integer, it will be in the form of 6q plus 1 or 6q plus 3 or 6q plus 5. For this you can take any positive odd integer. For example, you take 50. You divided it by 6. 6 2 is 12. The remainder will be 3. So this will become 3. This is satisfied. You take anything, that is 19 you take. 6 3 is 18. So remainder will be 1. 1 will be remainder, 3 will be remainder. You take 11, anything. 6 1 is 6 5. See, 1 3 5. You take any number, this will be always, it will be in the form of 6q plus 1, 6q plus 3 and 6q plus 5. Okay, we will go for next question. So now we will start this exercise 1.1 in that question number 3. Question number 3, an army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns? Here maximum, he has asked maximum. Maximum means highest. So highest. Here total 616 members are there. Okay. And they should be marched in the sequence of 32. So 32 group, in that they have to march. Now he has asked highest common, that is highest number of columns in which they can march. It is a calculation of HCF between 616 and 32. So calculate HCF of this one. Take the biggest number 616, divide it by 32, smallest one. 32 into 1, this is 32, minus 9, 2, then take 6. So 6 is there, means 3. 32 into 10 means 320. So just less than that, you will go for 9. So 9 into 2, 18, 1. Okay. 9 into 3, 27, 128. Okay. This is okay. So here 8. So 0, 0. So 8 is remaining. So this can be written in the form of same Euclid's division algorithm method. That is 616 is equal to 32 into 19 plus 8. This remainder is not becoming 0. So then go on dividing. This 8 is again divided by 32. So 8 4 is 32, becomes 0. You have to divide unless you get remainder becomes 0. So now we will write this one, 32 is equal to 8 into 4 plus 0. So now remainder becomes 0, means this will be the HCF of the given numbers. So this one, immediate divisor. 8 is the HCF of the given number. So in the 8 columns, we have to write the answer in the same way what the question is asked. What is the maximum number of columns in which they can march? That is 8. 8 number of columns into 8. So we will go for next question. Exercise 1.1. In that question number 4. Use Euclid's division lemma to show that the square of any positive integer is either in the form of 3m or in the form of 3m plus 1 for some integer m. Here he has given hint, let x be any positive integer, then it is of the form of 3q plus 1 or 3q plus 2. Now square each these and show that they can be rewritten in the form of 3m or 3m plus 1. So totally what they have asked, we have to show that any integer, square of any integer. For example, square of any integer, squares we will write. 1 square is 1, 2 square is 4, 3 square 9, 4 square 16, like this. This is square. If you divide this one by 3, for example 4 will take 3, 1s are 3, remainder will be 1. So you take 9 divided by 3, 3 3s are 9, remainder will be 0. 16 you take divided by 3, 3 5s are 15, remainder will be 1. So here you observe the remainders are always 1 or 0. That's what he is telling. That is 3m or 3m plus 1. So we can write A is equal to B into Q plus R. This B he has given 3. A is equal to 3Q plus R. So remainder we have to show that the square, this is square, A square, any square of the any integer is equal to 3Q plus R. So R is 0 or 1. We have seen that if you divide any integer square, that is square of any positive integer, will be in the form of 3m or 3m plus 1. That's what we have divided by 3. So we will get 1 or zeros. Other than that, nothing will come. Hence it is proved. Okay, we'll go for next question. So now exercise 1.1 question number 5. In this question, use Euclid division lemma to show that the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. Let A be any integer and B is equal to B, what we have to take here, 9m, 9m plus 1, 9m plus 8. We have to show this one. So the coefficient of m, 9. So B is equal to 9. Now as per the given question, the cube of any number is equal to 9 multiple of integer plus remainder. Here this remainder, it may be 0 to 8. In that we will get only 0, 1, 2 up to 8 we will get. We have to show that we will get only 0 and 1 and 8. All these are not possible, means they are not appearing. That we will see here. You take any number 2, cube of this number will be 8, divided by 9, 9 0 9 0, this is 8. So the remainder will be 8 only. So 8 we will get. And in the same way, you take cube of 3, that is 3 cube means 27, divided by 9, 9 3 is 27, the remainder will be 0. So we will get this. R equal to 0 means this is 9m, only 9m. Remainder is 8 means 9m plus 8. So now 4 4 is 16, 4 4 is 16, 16 4 is 64. 64 divided by 9, 9 7 is 63. So 1. This remainder will be 1. That is 9m plus 1. So the meaning of this question is, whatever the number, the cube of that number will be in the form of, that is the equation will be in the form of 9m or 9m plus 1 or 9m plus 8. That is remainder will be either 0, either 1 or either 8. Hence it is proved.